Good afternoon, everybody. Something we have often found useful is to spend a few minutes walking through how you get access to the resources at the ALCF and what the programs are and defining them for people. In part, so you understand maybe where you can go, but also because you'll see, as you're looking at different projects or even looking at websites, a lot of different programs, and you might try to understand, hey, how does this program relate to this one and what the relationship is. So we want to spend a few minutes walking through them. You, in the end, have probably seen some introduction to the computing resources. For the ALCF, going into 2019, we're allocating MIRA for its very last year and Theta. And so all the programs that I'm talking about, all the different allocation methods that I'm talking about, apply to both of these resources. In addition, I'll comment on a few other programs that we have that are related to our incoming exascale system. So in 21, we'll be deploying Aurora, the nation's first exascale system. And there are programs we have already. You'll get a sense of even maybe what that will look like for future resources if you're interested. And sort of understand, again, how to map what projects are what when you're trying to look into your own work. All right, so how do you gain access? There are three primary pipelines for access to the machine. And in the end, our machine is really broken down in terms of its time and availability into these three categories. The first one, sort of the first entrance mechanism, is the discretionary program, which is 20% of the machine. Then there's the ALCC, which is a program run directly out of Department of Energy, which I'll talk about, which is 20%, and the INCITE program, which is another 60%. So the majority of the time on the machine goes to INCITE, which is our peer-reviewed open science project. There's also more targeted projects that use the resource through actually our discretionary time, things like readiness for next generation platforms or moving a community forward, like ADSP, the data sciences and learning program. That's what that stands for. The early science program, which is part of our process for getting ready for next generation systems. All right. So what is the discretionary program? Really, in the end, the discretionary program is to get anybody ready to apply to all of the other programs. That's really what it's there for. So we use this for projects to come in who want to prepare an INCITE proposal, want to prepare an ALCC proposal. Within those proposals, you are required to provide some information about the readiness of your project, right? That you are capable of using large resources effectively. And the discretionary program is really the mechanism that we encourage people to go through that. Now, some people, that readiness is a 6-month endeavor, right? They need to get in, they need to port their code, and they need to do some scaling tests. Maybe they've already been running at scale elsewhere. For some people, that use of the discretionary program is more of a 2-year-long endeavor as they go from maybe using their university cluster to more leadership class scales. And so it's more of a long-term investment. For the discretionary, really, as I said, the purpose is sort of this first step access to leadership computing resources, the first step to working to a major allocation. Anyone is able to apply for this. There's no restrictions. You don't need a certain source of funding. You don't need to be at a particular type of institution. Anyone can apply. It's just sort of our primary constraint is that it's open science research. There is a simple review process. So one of the other things we try to do with discretionary is to keep it low overhead, right? So it's not apply, wait for 6 months, and hope the project makes it through a bunch of peer review. It's meant to take a month to 2 months at most. We really target more on the shorter time frame of a month of applying to actually getting on the machine and moving forward. So the requirements are not a long proposal. It's normally several paragraphs which articulate why you need to get access to the resource, what the work you want to do looks like what kind of runs you need to make. And so these are in part just to make sure that we can actually, you can actually execute the plan that you have in mind. But the awards tend to be smaller, right? So they are a smaller fraction of the machine. The total discretionary pool is a smaller fraction of the machine, and the discretionary pool is shared, as I said, with some other programs, some larger programs as well. So these don't tend to be INCITE scale allocations. They're small, targeted work to do scaling up. They also tend to be relatively short in duration. It's not that, say, after 3 or 6 months, you're kicked off the machine and say, we say goodbye, have fun. It's more that after 3 or 6 months, we're going to be asking you, say, give us an update. Where are you? Did you actually apply for the INCITE project that you were planning to apply for? If you didn't, why? So we can understand where your project is going. But in the end, this is meant to be a really low overhead, really easy entrance program. You can get access to both Theta and Mira through this, and basically at the other leadership computing facility as well. It's that's the same goal. You can get access to the big resources to the scale up that you need. I put ALCC and INCITE together a little bit. I don't always talk about them simultaneously. I'm going to talk more in detail about the INCITE program because in the end, the facilities, Oak Ridge and Argonne, we jointly run the INCITE program. And so I can give you a great deal of insight, no pun intended, into how that program runs. And there's a lot of similarity between the INCITE and ALCC, but I'm going to talk about them sort of a little bit together at first. These are the two primary programs to get large allocations on the DOE computing facilities. ALCC is more constrained than INCITE. So the differentiator for ALCC is that you have some DOE mission need. And this is run by our program office at the Department of Energy. They have a call in February. They go away and sort of figure out, did you apply, to solve a problem that DOE cares about, right? And is there another program office within DOE that cares about what you're trying to do? And that's the primary driver for ALCC. So that does have constraints. But as a result, right, they can be a little bit more flexible in ALCC. They might be giving smaller awards. They might be taking a bigger risk even with the readiness of a project to be able to use the large resources. In contrast for INCITE, as I mentioned, there are no constraints about where your funding source is, about where you're located, right? So anyone can apply. It is truly an open program. It's actually part of the core definition of a user facility for the Department of Energy. For anybody who's interested, like light sources share sort of the same constraint, that it is an open call. Anyone can apply. Anyone could potentially win time on the resource. So for INCITE, this is an annual call. So the call closes in the middle of the summer. It normally is first announced in April, and the end of June is when it closes. There is a twofold review process, which I'll talk a little bit more about in a little bit more detail. But fundamentally, the most important part of the review process is assessing the scientific impact of the project. So INCITE is really looking for those projects that, if successful, would have a very large impact on their field or even beyond, and are able to compete right against the other projects proposal. These are done by a peer panel. So we have actually several days locked in conference rooms every year. And we've collected different panels based on domain that actually sit down and have a conversation about every single proposal in that domain and give us input into the allocation process. It's really important input. The other part of the review process is the computational readiness. So it's important to consider for INCITE in the scale of awards that people get, we're talking about awards that are a huge fraction of an expensive machine. So while we don't tend to translate, what a large INCITE award is in terms of money, you can think about it in the sense of it costs millions and millions of dollars. You're getting millions of dollars of an award. So we want to make sure that those projects are actually ready to use the resource efficiently. So you could have the most world-changing project, right? But if you have nothing that can run at the facility, we'll try to help you, but it might not be ready for INCITE yet, right? So for INCITE, you really need to meet both of these, that you know how you're going to execute your problem on the machine in whatever way that may be, right? It doesn't have to be a big campaign. It could be a complicated workflow that you need to execute, but you know how you're going to do it, and you've demonstrated that you can do it. And as I said, the most important part, which is that you have competed successfully in the scientific peer review. The other thing to consider is that with INCITE, unlike the other programs, these are multi-year awards. So most projects that apply for INCITE, not all, but many of them, are 3-year awards. Most people apply anyway to have a 3-year award. And from the perspective of high-impact science, that normally actually works out pretty well in the sense that it might take 1 or 2 years to build up to a really large problem that you're trying to accomplish in your 3rd year. But every year, you would also still apply for a renewal to make sure that you're making appropriate progress. And the renewals are, again, addressed by those peer panels when we have our annual meeting. All right, so I've talked a little bit about the high impact. And as I mentioned, you have these primary criteria, which is the merit, the scientific merit, the second criteria, and and not the most important criteria, but still sort of an important entry criteria, is the computational readiness and the eligibility. As I said, for the most part, everyone is eligible. You can't be in a very small set of countries, it's about 5, but everyone otherwise is welcome to apply. The bigger constraint, and sometimes this impacts industry partners, is that the work has to be something that you will publish, right? It has to be open science. So for an industry partner who wants to apply and keep that work completely proprietary, that really requires a larger conversation with the facilities. All right. And I talked through these a little bit, but to give you a sense of what the review process is looking for, right? So in the scientific review, it's looking for the merit, right, the impact of the proposal, if the work is successful. It's also looking to make sure that the proposal is clear, right? So in the end, for a project, if you imagine, right, this is a 3-year project, right, and you're trying to you need to lay out clear milestones, so the reviewers understand how you're going to get to your endpoint, right? In the end, this is just basic proposal craft, right? But it's something to keep in mind, right, that you're having experts in your field, maybe not experts in your exact work, but experts in your field read this, and you need to make sure that you've got clear milestones and a clear path to success laid out in that proposal. This is actually a big challenge in a lot of proposals where they've got milestones that are really vague, and so you've got reviewers going, I really like the end product, but I have no idea how they go from here, where they are today, to where they're going. And that leaves them with doubt, right? And so this is just proposal craft, remove the doubt. Have good milestones and a good path. One of the other big criteria we ask the peer panels to look at are the qualifications of the team. So not only, that you've got a PI, right, who should be driving this research, who is a good person to be driving this research, but that other people on the team, perhaps the co-Is or even just the team that you've lined up who are not co-investigators, right, but to execute the work, are there, they're capable of doing this, they're ready to do this. And it's not, and it's not that you need 5 people that you haven't hired yet, but no, I promise I'll find 5 people and hire them in the next 2 months. Right, that's a much riskier thing to put into place. So you need both the domain experts, but also the people in place ready to execute. One of the other things we look at, and this overlaps with the computational readiness, is your requested time. Remember, we're talking about time that in many respects is worth millions of dollars, and is a large fraction of an expensive machine. Is the amount of time you requested reasonable? Right. So the people on the panels have experienced solving many of these types of problems on large resources or moderate scale resources. And so one of the questions they're asking themselves is, given the potential impact of this problem, is it worth the resources that they're asking? And given their approach, right, your methods and your application, are those appropriate, right? Does that actually give an efficient solution to the problem? It doesn't necessarily always have to be the most efficient possible way, right? But is it reasonable? And is it something that is worth the facility making the investment in? And the renewal assessment, so as I said, these are multiple year awards, right? So the renewal assessment doesn't go back and do the merit assessment as carefully as it was done in the first year. Really, on the renewals, we're making sure that you're making progress, right? We want to understand if a project is actually going forward on the milestones it proposed, if it's still in the same scope of science that it proposed, right? In the end, this absolutely happens to projects, right? You're trying to solve a problem and another question comes up that's more urgent, right? Like that's maybe a problem or even a question that you didn't expect as you were thinking about your original plan, a new question in your science. And you have to sort of shift gears and start answering that one. There's a real question, and you can talk to the INCITE, you can talk to the facilities, you can talk to INCITE program managers, you can talk to me about whether, is that a change in scope? Am I solving now a whole entire different problem? And if it is solving a different problem, it's actually normally better to go back and to do a new proposal, because that change in scope is often something that sends a lot of flags up, just sort of asking why. And if it's a big change in scope, then really assessing what the question is, what the impact is, and the approach really wants to be, our hope is that we can reset and come back to that. And then generally just sort of answering some basic things like, is everything still going as planned overall? For the computational readiness review, I sort of talked a little bit about this. The fundamental thing we're looking at the computational readiness is, are you ready to go? Or how ready to go are you? If you've got a complicated workflow, and this is just the more this is I think one of the more complicated ones, right? So for a project that has a big campaign and they need to take one code and run that code for a month, it might be more straightforward what readiness means. You take that code, can you run the problem you want to run? Let's demonstrate that. Can you run it at the scale you're going to run it at? Okay, demonstrate that. And demonstrate you know what you're going to do with all the data you get afterwards. That's pretty clear. For workflow problems, I'll tell you from experience, if you've got something that's, not just run a big simulation, but you've got any flavor of sort of a sequence of problems that you need to be doing, you need some framework that's helping you manage, not just the parts that are running on the compute nodes, right? But you've got a framework that's going to help you do that. Make sure you understand how all of those parts are going to run. And make sure that you can demonstrate that all of those parts are going to run. And we, again, that's what the discretionary program is for. That's what we are here for. If you're not sure if you have to demonstrate if something should work, ask. But that's because that's the core part of the readiness. If you're not ready to run, how long will it take you to get to run? And often that's a big roadblock for people, right? So if there's something that's never been brought, right, to Theta before or never been brought to an equivalent machine, sometimes that ready-to-run part can take a very long time. And so from our risk assessment and making awards from INCITE, we're going to look very carefully at a project that hasn't demonstrated that. I'll say that for ALCC, they go through a very similar process, but one that's completely it's not one that we don't control. It is completely handled by our program office. They execute their own peer review. It is not quite the same. It is not sit down in a room necessarily and review the proposals. And they do a cursory computational readiness review, asking many of the same questions in both cases. However, they've got a different aspect in the peer review, which is how does this relate to DOE mission? All right. And just some statistics. Now, I admit these are 2017 statistics, and we're going into 2019, but multiple, we know we have not rerun the statistics for 2018, so that's why I will apologize in advance for this. But the relevant points are still consistent. And so why we bring up some of the statistics is to demonstrate to people that new proposals absolutely have a fighting chance. It is a highly competitive program. We're normally multiple times oversubscribed, 3 to 5 times oversubscribed within an INCITE. But that doesn't mean that the same PIs are just renewing constantly and there's no window where anybody gets time. So, for example, in this particular year, we had 55 projects awarded, 17 were renewals, right? And that does kind of vary from year to year, meaning how many were renewals kind of just varies whether we've gotten a nice sort of confluence of renewals that year that are or projects that year that are expiring. But that's a pretty consistent, that's a pretty consistent number. Like last year, but last year, for example, it was much lower. The renewals were a much smaller number, and I'm just not going to try to speculate. But renewals also have a much higher chance of success. You're not going through as competitive of a review. You're making sure that you're on progress, right? So the other thing to consider, if you're successful in that multi-year award, you're more likely to be able to continue forward. The other thing that's useful for people to understand is the scale of time. Now, as I said, these were old statistics. Almost all the numbers for INCITE and ALCC, we are moving to node hours just because cores become more and more ambiguous as time goes on and architecture changes. But this gives you a quick sense, and I can give you I can relate these to totals of what the average award sizes are. So for Mira, when this was running, the average award was 117 million. Last year it was larger than that. It was closer to about 160 million. We're allocating about 3.5 billion within INCITE. So we're allocating projects, that on average, right, are representing a pretty big fraction of that 3.5 billion. And we had projects that represented up to 10% of that, right? So we had projects that were nearly at the 300 million mark. So just for Mira, for example, you can just divide by 16, and these are all sort of equivalent. And I'll give you a sense of what the more specific numbers look like. But we're talking about big projects. ALCC does tend to trend a little bit lower because of multiple reasons. In part, it tends to be that they're taking a little bit more of a risk with some projects, and also to sort of serve an in-between category of somebody who might not have an in-between their university resource and a leadership computing facility. And this is what I was mentioning before. So we also, that new PIs do have a fighting chance. It is not, the same set of PIs who compete every year, who've had renewals, are always on the docket. That's not true. Even though you might recognize a name from one year to another, we've absolutely had historical PIs who are not successful in one year. And so in this particular year, almost half of PIs had never led an INCITE proposal at all, meaning they had never been the PI on a proposal ever. Now, they might have been a co-I, but they were not the primary on a proposal. I bring this up. I think this is one of the most important statistics, right, in the sense of if you're thinking about whether you have a chance to compete, where you do. But it's that, overall a 30% acceptance rate as well, right, which is also not the lowest it could be, right, but still pretty competitive. I talked a lot about ALCC. This sort of quick reference will be in the slides. And this is the other thing that I think is useful to have in the slides. It's just sort of like the eye chart version of the allocation programs. And gives you a quick sense of what you might expect. These are in node hours and not in core hours. So for node hours on Mira, now in the end, that INCITE year is closed, but it's about it is 220 million for INCITE on Mira in a particular year. It's almost 18 million node hours on Theta for a year total that will go to the program. The thing I'll point out about the discretionary, and this leads into my next couple slides, is that the director's discretionary, as I mentioned, and I think this is mostly relevant for this audience, is really used as that preparation place, right, to come in, to get access, to get stuff working, to prepare a proposal. Out of this discretionary time, however, we also support one sort of key Department of Energy program, the Exascale Computing program, and their application and software technology projects get access through this, which is why it's 20%. Historically, if you've ever seen this chart before, you're going, that looks a little different. It does look different because it used to be 60-30 and 10, and now it is 60-20 and 20. But that's because in the end, this program, with a very large investment from DOE, has been rolled up into support here. Two of the other programs that we support out of discretionary are targeted projects, right? So for the data science program, this is really intended to both train us and train the community, right, in how projects that are data-driven, learning-driven, complicated workflow-driven, train both of us on how to use leadership computing for these types of projects, right? That no one would argue that the whole history of designing supercomputers really often centered around traditional big simulation. And that's not, even the people who traditionally did big simulation are actually bringing forward very much more complicated problems to us and saying, well, I still want to do some simulation, but look, it's a lot more complicated. I've got 5,000 other things I also want to be doing at the same time with those simulation results, so help me out. So we started this program 3 years ago as a way to both bring in people with interesting, compelling problems to teach us, and then to learn from that to learn how we can train the larger community. And so we can design our facility better for those types of problems, and vice versa, and sort of switching that around, train people to come in and be more successful using these big computers for these types of problems. All right, and I only point this out because it might be interesting as you're trying to figure out where does this go. Our machine is only split up 60-30-10 or 60-20-20. Our math is pretty absolute. This is where these are coming from. The other program that you might see reference to is our early science program, and this is something we've always executed. When we are bringing in a new machine, when we're thinking about that machine in the early stages, years before it actually comes on the floor, we're trying to make that machine as effective for science problems as possible. And that includes everything from the hardware design, insofar as we can impact it, and when that is, hardware decisions are made much earlier, but then also in the software stack. And so we bring early science projects in who have campaigns that they would find interesting to run on next generation platforms, and who are willing to take some risks and sort of gamble a little bit, right, in a sort of more volatile, more broken environment of what would be the early stages in the machine before it's otherwise open to the public. So we collaborate with those projects to push the readiness and improve the readiness of the machines, and in thanks for them working with us to do this and to break the system as much as possible before it goes production, they also have a chance to run some large campaigns before we go into production and open it up to the community. This is often really valuable as it sort of offers sort of that final burn-in time for the machine when we might find any issues. So this is currently executing for Aurora right now. So we have projects both in simulation, data, and learning that have been selected and are working with us to get Aurora ready for the community. That is it. There's sort of some more detailed slides on the data science and early science programs if you're curious within the deck. But I sort of said most of it because I just keep talking and sometimes forget to advance the slides. Thanks.